So let's take a look. Is that on there? There we go. All right, so let's take a look at the second part of this. So yesterday, what type of, we named the way to solve for x and y yesterday. What did we name that? Substitution, right. Substitution. So that's what we did yesterday. Today, we are going to learn how to solve this system by what? Elimination. Now, I believe on a quiz or a test, I don't specify that you have to do it by substitution or you have to do it by elimination. I think, I'm just going by my memory right now, which isn't always that great, but I think I just say just solve the solution, all right, solve the system of equations, and you just solve for x and y, all right, but I want you to see both ways, because sometimes substitution is the better way to approach it. Sometimes elimination is the best way to approach it. So you need to have both of those skills, right, in your pocket, pull it out and say, boom, I'm going to use substitution on this one, or boom, I'm going to use elimination on this one. So I think it's important that you do know how to do both ways. So the first one we're going to do with elimination is it's tailor-made for you. I mean, it's like, it can't get much easier. You could get just a little bit easier on this, but this is Algebra 2, but anyway, so, but this is, I mean, again, you could do this by substitution, but I think elimination is the best way for this. All right. Now, when you have this system of equations, remember, these go together, all right? That's why that a lot of times they put that little brace right there. They go together. So what you can do is, you know how whatever you do to one side, you do to the other side kind of thing? That's what we can do here. So I'm allowed in algebra to line them up, the x's, the y's, and the numbers. I'm allowed to take them and either add them all up or subtract them. You follow me on that? All right, because whatever you do to one side over here, you do to this side, and if I add those, I can add everything. If I subtract this from this, I got to subtract everything from this, okay? Some teachers teach there are times to subtract, there's some times to add. When I teach this elimination method, I think always adding, all right? But if I added these together, is it going to eliminate? Is it going to get rid of? Is it going to cancel anything out if I add those columns together? No. All right, because that would give you a 3x, that would give you a 2y, that would give you a 3. Nothing, we didn't get rid of anything. We didn't eliminate any variable. So that's not really going to help you. So adding is not going to help, but if you added a negative, do you see what could eliminate here very easily? Which one could you eliminate very easily here if I added a negative? The y's, right? Okay, so if I made this a minus y instead of a plus y, then when I add those up, then that would add up to 0. It would cancel out, wouldn't it? And then what am I left with then? Just an x. And then I can solve for x. Does that make sense? So that's what I'm trying to do. I'm trying to look to see what can I do to either the x's or the y's to get them to eliminate. Well, I could, if I made this negative, then they'll eliminate. They'll go away. So how do I do that? Can I just make it negative? Well, I kind of can. Right? As long as I don't just make this one negative, I do what? I make everything on that equation negative. So really what I'm doing is I'm multiplying this by a negative. I'm multiplying, let's do this. I'm multiplying this by a negative. And I'm multiplying the other side, right? Whatever you do to the left, you got to do to the right. So if I multiply everything by a negative here and everything by a negative here, I didn't really change the value of that equation. I'm allowed to do that. Would you agree with that? Yeah, you're always taught in Algebra 1. Whatever you do to one side, you got to do it to the other side. And that's exactly what we did. Multiplied everything by a negative 1 here, multiply everything by a negative 1 there. Why did we do that? What was the purpose in doing that? That's it. So when I add them up now, okay, so when I add up my columns, the y's will add up to 0. Everybody see that? And we eliminated. I could have eliminated the x's if I wanted to, but the y's were so much easier. So that's why I decided to do that. All right? I could eliminate either side. It doesn't matter. All right? But that's a lot easier. So now let's add up the columns now. Remember, we're going to always add up the columns. All right? So that means if we add them up, we want to get rid of something. One's got to be positive and one's got to be negative. All right? So what happens here? This is a 1x. What's 1x minus 2x? Negative 1x. That's right. So it's negative x. What happened right here? Positive y minus y. They eliminate, don't they? They cancel out. All right? They add up to 0. We got rid of them, however you want to say it. Okay? They used the word elimination, so we eliminated them. All right? So that's nothing. Then equals 1 minus 2. What's 1 minus 2? Negative 1. Now I can get x by itself. You're like, I thought x is already by itself. Well, not quite. What's it got with it? It's got that negative. So let's multiply everything by a negative. Multiply that by a negative. That gives you positive. Multiply that by a negative. That gives you a positive. So x is equal to 1. Are we done? Do we circle that? Do we go on to the next problem? No. We got to solve for the y as well. And we also need to write our answer. I harped on this a lot yesterday. How do we write our answer? As an ordered pair. Okay, as an ordered pair. So I'm not going to circle this just yet. All right, let's solve for y. Even though this is called elimination, the next step is going to be substitution. So elimination is kind of like, well, you eliminate first, and then you go back to the substitution. So I could solve for a y either in this top equation or the bottom equation. It doesn't matter which one. Let's just use the top one. It's already positive y. Remember that was, I don't need to put the 1 there. It was x plus y equals 1. Now let's put the x, or the 1, in for the x right here. So it's just 1 plus y equals 1. Subtract a 1. What's y? Did I do that right? I did not do that right, did I? Oh, yeah, it was. Well, that's okay. Yeah, I was going to say, I looked at my answer. I'm like, that's not the same answer as I have. It's because I didn't put negative 1 there, but we'll just keep it like this. It still works out perfectly fine. All right, so subtract 1 from both sides. 1 minus 1 is 0, so y is 0. So how do I write my answer? I write my answer as an ordered pair. What goes first? The 1, and then the 0 goes next. Now I can circle it. You're right. On the example, this is example 3 in the book. This is actually a negative 1, and I messed up a little bit. But still, what I did works perfectly fine. Make sense? Well, if they're both positive, one's going to have to be negative. All right? It all depends. We're going to, well, then you're good. If it's already 1 positive and 1 negative, then you can eliminate them right there and then. All right. So what if this problem was this? It's not, but what if it was? And 2x minus y equals 2. What if that was your problem? Then right now it's already it's made to just eliminate right now. You don't have to change anything, do you? Would you agree? Because this is already a positive y, it's already a negative y. Bang, bang, there you go. Add up your columns. That's 3x equals 3. X is 1. All right, then you can plug it back in, do the same deal. All right, but in the original case that we had, remember, this was a plus. I got rid of it and made it a minus. All right, let's do another one. They jumped right into it on this one. If this was Algebra 1, they'd probably give you something just a little bit harder than what we just did. This one, they really ramp it up a little bit from example 3 to example 4. But I think they're also working on the expectation that you probably have done this before. This is probably not your first time doing this. And I think for the most part, most of you guys said you've seen this before, correct? Elimination. But if you didn't, it's fine. I'm showing you how to do it, even if you didn't know how to do it before. So let's write this down. That's a 7. I was considering redoing this problem and eliminating the x's just to show you it wouldn't make any difference. But I decided against that just because I want to make sure we get this finished. But you don't just have to get rid of the y's every single time. All right, you could get rid of the x's or you could get rid of the y's. How do I determine which one I want to get rid of? Well, I look at the one that's probably the easiest way to do it. All right, and I think you would like that way too, wouldn't you?
So essentially we find one to eliminate and take that number and substitute it.
Yep. So on this one, like the 7 and the 5, they aren't the same. So it's not just a matter of making one negative, because if I add them up, I'm still not going to get it. I'm not going to be able to cancel them out. Right here, if I just make one of these negative, will the y's cancel out? No. But I could do this. I could find a least common multiple. Remember what that is? It's a number that both numbers divide into evenly. The smallest number, least, right? Least common. The smallest number that each number will divide into evenly. What would that be with 7 and 5? Well, the least common multiple wouldn't be 5 and 7. What single number does 7 divide into and 5 divide into evenly? 35. 35, all right? Because 7 divides into 35 5 times, right? 5 divides into 35 7 times, right? And that's the smallest number that both of these go into. Do you agree? So I'd have to change that to a 35 and have to change that to a 35. What about the 6 and the 2? 6 would be your common, it's like a common denominator, right? Least common multiple is kind of like a common denominator. What would it be? It would be 6. So that way, I'd only have to change one of these. Right here, I'd have to change the 7 to a 35. I have to change the 5 to a 35. If I wanted to eliminate the y's, all I'd have to get rid of, or all I'd have to change, I should say, is this 2y to not just a 6y, but into a what? A negative 6y, right? Because when I add them up, they need to add up to 0, right? Because they're both positive here. So one's going to have to be negative. So here's what I'm going to do. Now, I can't just change this one. I got to change the whole thing. So what am I going to do? I'm going to multiply this by what? A 3? A negative 3. Why am I multiplying everything by a negative 3? Because it's going to turn that into a what? A negative 6y. Then, on the next step, the 6y and the minus 6y will eliminate. They'll cancel out. Does that make sense? So how do I make this a negative 6y? I multiply by a negative 3. I can't just multiply this by a negative 3. I got to multiply the whole left side by a negative 3. And what else? The right side by a negative 3. Make sense? Let's do this. Let's go back to white. All right, so let's rewrite this so it looks a little bit nicer. So I'm not really messing with the top, because I didn't do anything to that top equation, but I definitely did something to the bottom equation. What's this going to give me? Negative 3 times 5x, negative 15x, and then negative 3 times 2y. There's your negative 6y. That's the whole reason, right there. That's the whole reason why I did this stuff, so that this 6y and 6y down here will add up to 0. Yes?
So we're adding or are we subtracting? Because I thought elimination.
We're always add. I always add. There are some teachers that say you subtract. Like if this was a positive 6y, some teachers would say subtract them. All right, but then sometimes you're adding, sometimes you're subtracting. I like to stay consistent and always add up my columns. I just think it's easier that way. It just keeps, it's one less thing to worry about. But on the other hand, you had to make that a negative though, if you're going to add up the columns. Okay, so it goes either way. Equals what? Negative 3. Now, I've got the same variable. One's positive, one's negative. You know they're going to cancel out when I add them together. So let's add everything together. 7x minus 15x. What's that? Negative 8x. All right, here's the whole deal right here. This is the elimination, right? This will eliminate. They'll go away. They cancel out. They add up to 0, however you want to say it. Equals what? Negative 4 plus negative 3 is negative 7. Everybody good? One more step to get x by itself. Divide everything by a negative 8. Divide this by a negative 8. So what is x? 7 over 8. And it's a positive 7 over 8. Everybody good? Yes, ma'am. No. Yeah, I said earlier, it doesn't matter which one. Okay, you could have eliminated, and in fact, in my notes even, we're going to eliminate the x's. We're going to just do it a different way just to show you that it doesn't matter which one you eliminate, okay? But I think this is the easiest way. Now, look at that number, though. That's an ugly number, isn't it? 7/8. Do you like dealing with 7/8? Not really, but sometimes you just got to deal with it, all right? So I think what I did, yeah, let's just deal with it. Now I got to take this and plug it in. Plug it in either here or take this x and plug it in right here. It doesn't make any difference. I don't think there's a preference one way or the other. I don't think either way is going to be real pretty. But which one would you substitute it in for? The top one or the bottom one? The bottom one? All right, let's do the bottom one. Why? Just numbers a little smaller? Yeah, probably. All right. What was your question?
How would you do it if you would eliminate the x instead of the y?
That's what I just said about rewind the video about 30 seconds. And I say I'm going to do it after this. I'm going to eliminate the x's and show you the difference. Okay, you're still going to get the same answer, but I'm just going to show you how to eliminate it if you want to eliminate the x's. You can do it either way, all right? And I will show you both ways. Do you have to do it both ways? No. You pick which way you want to do it, and you do it that way. All right, so let's plug this in. So, again, this is going to be a little ugly. We're going to have to deal with fractions, but, you know, sometimes life is like that. So here we go. 5 times, I'll put it over 1 because I'm multiplying it by a fraction, which is 7/8, plus 2y equals 1, right? That's the original equation, right, without all this stuff being multiplied by negative 3. All right, so what do we get here? Nothing cancels out, right? So that's what? 35 over 8 plus 2y equals 1. Let's subtract 35 over 8. So I subtract, let's do it right here, 35 over 8. I don't have to show it here. I know that's going to cancel out. What do I do here, though? Yeah, I got to find a common denominator there, don't I? All right, if I'm going to subtract those, I got to find a common denominator. How am I going to rewrite 1? 8 over 8, right. So put 8 over 8. So now I got 8 over 8 minus 35 over 8. And what is that? 27, negative 27, is that right? Did I do the math right? Negative 27 over 8 equals 2y. That was the hardest part, I think, right there, is just find a common denominator. Well, for most students, that's the hardest part. Now what do? Divide by 2. But it is a fraction, all right? So what's the same thing as dividing by 2? Multiplying by what? Nobody? Say it. I heard somebody say it. Right. Multiply it by a half. You got it. It's the same thing as dividing by 2, isn't it? Why in the world would I just all of a sudden multiply by a half instead of divide that by 2? Because it's a fraction, right? And that's what we're going to have to do eventually anyway, right? If I put this over 2, I'm going to have to multiply by 1 over 2. All right? And here's the answer. Negative 27 over what? 16. 4 times 2. It's not 4. Or 4. I said 4 because you said 4. 8 times 2 is what? 16. So there's my y. Yes, ma'am. You might. Okay, if I show you how to do it and you get fractions, there's always that possibility on a quiz or a test you could get fractions. Absolutely. You got to know how to work with fractions. All right. So, how do I write my answer? As an ordered pair. So 7/8 negative 27/16. Couldn't be any uglier, could it? I guess it could be, but that's pretty ugly right there. See, that's a good point. If I asked you to solve this thing by graphing, is there any way, no matter how accurate you were, you'd ever come up with those numbers? There's no way in the world you would, okay? So solving by graphing is good every once in a while. It's not always great because you might get ugly numbers like this. And I kind of think that's why they gave you this, just to show you that, you know, doing it algebraically gives you exact answers. Doing it graphically, especially when it doesn't meet right at the intersection on those graph lines, there's no way I would guess that. Okay? All right. You want to do that same problem a different way? I don't know if it's any easier or not, but I'll just show you. I'll tell you what, let me look ahead first before I decide if I want to do that. Yeah, I think I got time. When's this over? 25? Okay, yeah, I got time. All right, so let's do the same exact problem. I'll go a little faster this time though, okay? So we don't drag on so long. So I'm going to write the same exact problem, but this time we're going to eliminate the x's instead of the y's. And then you can decide what you would rather do if you had to do this on your own. Okay? I don't need that thing. We know it's there. All right, we want to eliminate the x's. We talked about this before, so we want to make those x's what? 35. So what am I going to do to the 7 to make that a 35? So I multiply everything on the left by a 5 and everything on the right by a 5. I got to make this not just a 35. What do I want to make it? A negative 35. So I have a positive and a negative. I could have made the top negative 5, right, negative 35, couldn't I? All right, but I don't know. I just kind of like to do the second one, negative. All right, but what am I going to have to multiply that by? Negative 7. All right, because that'll make it. Okay.
Thank you.
So this will make that a negative 35. Are you watching? All right, so I'm going to have a positive 35. I'm going to have a negative 35. They will do what? Yeah, what's the word we're using, though, in this lesson? They'll eliminate. That's right. They'll eliminate. Cancel out's fine, but I just want us to say eliminate since that's the word for the day. All right. Now, let's push this over here, and let's see what we get. So what do we get over here? 35x plus 30y, right? Distributing that 5 equals negative 20. Let's multiply this through. That's negative 35x minus 14y equals negative 7. Now, I'm ready to do the elimination. That will cancel out or eliminate. And now, again, I'm adding everything together. So it's 30 plus negative, or just 30 minus 14. What's that, 16y? And that is negative 27. Divide everything by 16. And then y is negative 27 over 16. Does that look familiar? Yeah, it's the same exact y that we got before. But now what do we have to do? We got to solve for x. All right, so I'm going to take that y and plug it in. Anywhere you see an x, you could plug it in. You could plug it into one of these. I wouldn't do that because those numbers are a lot bigger, right? So I'd pick one of the original ones. Which one do you want to pick? The bottom one again? All right, might as well. So I've got 5x plus 2y. So it's 2 over 1 times y, which is negative 27 over 16, equals negative 7. All right, drop down the 5x. What happens here? Something happens here that didn't happen in the other one. The 2 goes into 16, what? 8 times. You see that? So what is this going to be? Minus 27 over 8. And that equals negative 7. I can see it in your faces. You hate these fractions, don't you? All right. It's really not that hard. I mean, you just find that was easy, right? The 2 goes into 16. Now you just got to find a common denominator, because what are we going to do here? We're going to add a 27/8, and I'm going to add a 27/8 to this. Right? So I added a 27/8, didn't have to show it. I know it's going to cancel out. Bring down the 5x. What am I going to do here? How am I going to rewrite that? I want it as a denominator with 8, right? So I'm just going to go 8 times 7. What's 8 times 7? 56, and it's a negative 56. Isn't that the same as negative 7? Yeah, so there's negative 7 plus 27/8, and what's that going to be? Is that negative 27? Or what's 56 minus 27? No, it's not that. What is it? What is it? 25? 29? It should be a 9, right? So negative 29/8? Yes? Okay. Divide by 5. But again, instead of dividing, since it's a fraction, what am I going to do? Multiply it by 1 over 5. X equals. What are we going to do here? Does anything... did I do that right? I messed up somewhere. Well, it's just my arithmetic. I didn't want to use calculator, but I'm going to. Is that negative 29? 56 minus 27. Yeah, it is 29. It's negative 29 times that. 29 over 40. But that won't reduce. All right, where did we go wrong? Went wrong somewhere. Got that right. Did I put it in the equation correctly? 5x plus 2y. Oh, here's what I did. No. It's this. Look, nobody stopped me on this. Look, I put negative 7. It's not equal to negative 7. What was the original one equal to? It was equal to 1. That's where I messed up. Right? Because I put a negative 7. Right? Got just the white ones I should have put down. 5x plus 2y equals 1. Now, add a 27 to both sides. And so that's what? 8 or 27/8. So that's an 8 over 8 plus 27 over 8. Did I do that right? Yep. That's 35 over 8. Let's get rid of all this. All right, so I've got 5x equals, what did I say that was, 35 over 8? And then divide by 5 or multiply by 1/5. There we go. Goodness gracious. Something so dumb, and that was dumb on my part. Would you agree? Yeah, I put a negative 7 instead of a 1. So I didn't really do my math wrong. I just didn't write it down correctly. And so what happens here? This 5 goes into 35 7 times. So what's x? 7/8. Write the answer. 7/8. Negative 27/16. And that can be circled. Does that look familiar? Yep, there it is right there. So on this one, it was fine, but you'd have to multiply both things by a number, right? But after that, it's really not that much more difficult. But at least on this one, you only had to multiply one of the equations by a number. All right, so if it was me, I'd probably do it this first way right here. All right. Sorry for the hang up there, but it's good for you to see that I mess up too. All right, believe me, you hang around me enough, you'll see that I make a lot of mistakes. But I figured it out though, didn't I? All right, went back, looked at the problem, figured it out, and that's what you need to do as well. All right, let's do one more. So this is example 5. What we're going to do is we're going to look at them and see if they are dependent or, dependent or inconsistent. Do you remember that word from, what was that, 2 days ago?
Yeah.
Or was it yesterday? 2 days ago. All right, so I'm going to go a little faster because now I'm watching the clock. Make sure I write it down correctly. Don't be a bozo like I did on the first one. All right. You can solve this any way that you want. It doesn't make any difference. All right. So what would you use? Would you use substitution or would you use elimination on this? Yeah, let's use elimination. What would you eliminate? What do you think the easiest one to eliminate would be? I'd probably say the y's. Either way, to tell you the truth, I don't think one's easier than the other. But when I first saw it, I saw the y's since it has a coefficient of 1 right here. Okay, but really all you have to do is multiply that by -4. Those will go. Or you multiply this by a what? Another -4. So either way you do it, it doesn't make any difference. There's all kinds of ways you could look at it. All right, so what do we get? 8x minus 4y equals 1. And then we get -8x plus 4y. Ooh, I see something weird. Do you see something weird? They both eliminate, don't they? That's crazy. So I got this will eliminate to 0. This will eliminate to 0. So if I add everything up, I got 0 equals what? 13. Is that true? Does 0 equal 13? No, for one thing, that's false. For another thing, where'd my x's and y's go? They're all gone. So what do you think the answer for this would be? That's right. So this is not true, right? It's false. So if that's a false statement, then it's inconsistent. Yeah, on this one, they just ask you classify it as dependent or inconsistent. All right, dependent or inconsistent. That's the only two choices they give for this. What do we know about two lines that are inconsistent? They're parallel to each other. So just for fun, let's see if they really are parallel to each other. How can I determine if they are parallel to each other? Find the slopes. That's right. So let's put them both in the slope-intercept form, okay? Let's take that top one. We'll do it really fast. Shouldn't take too long. Subtract an 8x from both sides. Divide by -4. Really, all I care about is the slope anyway, isn't it? But let's just divide everything by -4. So what is this? Y equals what? 2x minus 1/4. What's the slope of that? It's 2. Let's do this one. Let's find the slope of this one. All right. So I've got 2x minus y equals -3. I could move the y to the right-hand side, but let's just do it the way we've been doing it. Subtract a 2x from both sides. So I get -y equals -2x minus 3. Multiply or divide by a -1. I'll divide by a -1. So what do you get? Y equals 2x plus 3. Check it out. What's true about these? They're parallel, aren't they? That's why this happened right here, because they don't have any points that are not connected, but point of intersection, okay? They don't have any points that are in common. That's what I was thinking of. They don't have any points that are in common. That way, that's what happens when you did that elimination and substitution, okay? Does that make sense? And this, now, did you have to go through all this stuff? You didn't. I just did, just to show you that, yeah, they're definitely parallel to each other, so there's no point in common with both of those. Let's do one more and we'll quit. 2x plus 3y equals 4. And then 10x plus 15y equals 20. Let's just do this. Now, you might be tempted into going and doing substitution and elimination. But when I'm looking at this, I'm like, there's something fishy about this second one and this first one. Because look, is there something in common with all three of these? Yeah, they all have 5 in it, right? So divide this by 5, divide that by 5, and divide that by 5. And what are you left with? You get 2x, what? Plus 3y equals 4. Look at this, and look at this. They're both the same exact equation. So if I was to graph them, then every single point would be in common, right? And what do we call that? That would be dependent, okay? So the question they ask, is it dependent or independent? It would be dependent. If you wanted to, you could have done elimination and you could have done substitution, and you would have found out that the x's and the y's still cancel out. But remember on the other one, where those things did not equal each other, you're going to come up with two numbers. And I didn't do it this way, so I don't know what those two numbers would be. But you would come up with two numbers actually equaling each other, the same thing on the left and the right. That's a true statement, right? I don't know what it comes out to. Let's say 5 equals 5, right? That's a true statement. So if it's a true statement, you know that both equations are exactly the same. So no matter what x and y you put in, it doesn't matter. It's going to be the same, right? Because they're the same equations. Yes?
On the homework, it says independent, consistent. What's that?
Yeah. Let me look at it. So because again, these are kind of new to me too, and I'd have to look at my notes, and my notes are on my table across the way. So what was it? It was independent, consistent, or independent. What were the topics? There's 3 of them. So independent, dependent, and consistent. Or okay, independent, consistent, dependent, consistent, and then inconsistent. Okay, so the independent consistent would just be 2 regular lines that cross each other at one point. Is that correct? And then the dependent consistent would be no, that would be like this, right? Like this one right here, okay? And then inconsistent would be if they're parallel and then don't have any intersection at all. All right, so that's what that is. Yes?
Can we just add on to the homework?
That's what I wanted to do. I wanted to take a look to see. Oops, I'm on the wrong lesson. 3-2. And I had you do up to 10 yesterday, right? I'll tell you what. I will not have you do 11 to 14. All right, that's what I would normally have done. But you're going to have a chance to do it. It would just be, I don't know, just monotonous work. All right, so let's go 18 to 30. Let's do 18 to 30. I think that's what I originally had for today anyway. So I think that works well. So we'll call it section 3-2B. And we'll do 18 to 30. Everybody okay with that? Yeah. So we won't do up to 14 because you're going to have to do elimination on some of these anyway, this 18 to 30. So you'll get your practice in by doing elimination. All right, so I think that's fine. All right, that's it.